So this lesson is a quick review of the distributive property. Much like the other lessons, we're not going to spend a whole lot of time talking about exactly what the distributive property is, but we are going to look at that algebraic formula that we had. We're going to go through a few examples on pretty much all the different cases you might find with the distributive property, and I'll give you 4 problems to work on at the end. At any point during the video when we are working through the example problems, you are welcome to pause the video and work through those instead on your own, and I encourage you to do so if you are confident in doing that, or even if you aren't, to see what it is that you remember and the place that you're at, rather than just waiting for the last 4 places at the end. So really the distributive property can be summed up in sort of 2 algebraic phrases, and they are pretty much exactly the same except for the operation that's in the middle. And it's significant that the operations are changed because this concept of distributing your multiplication, which is your A, over the addition applies both to distributing over addition and distributing over subtraction. So the multiplication of something by a sum in parentheses is just going to be that one thing, that A, multiplied by both B and C. And if we had plus D, plus E, plus F, etc., in the parentheses, that A would be multiplied by each of those 2. Similarly, if our parentheses phrase is B minus C, and the entire thing is multiplied by A, then that A gets multiplied by everything in those parentheses again, the B, the C, and we could continue with minus D, E, F, etc. And this comes back, remember, for the demonstration we did in class, that if you take an entire set of things, as we did with the foam blocks, and you create multiple copies of the set, everything in the set must get multiplied, not just certain parts in it. So let's go into those example problems first. We have 2 problems here, 3 times x plus 4 and 4 times 7 plus y. For the first one, the 3 has to get multiplied by both the x and the 4. So 3x and 3 times 4, keeping the addition between, so it becomes 3x plus 12. In the second problem, we have 4 multiplied by 7 and 4 multiplied by y, so 4 times 7 plus 4 times y, which gives us 28 plus 4y. Notice in both of these, the 3 and the 4, the number outside the parentheses is being multiplied, is multiplied by everything inside the phrase, inside the parentheses, inside by each term in that expression, and we keep whatever operation is going on between it. So 3x plus 12 and 28 plus 4y. Another set of 2 problems, negative 2 times the expression x plus 4, and negative 3 times the expression x plus y plus 7. So for negative 2 times x plus 4, we have negative 2 times x, which is negative 2x. Keep the operation, plus negative 2 times 4. Now, negative 2 times 4, as you'll recall, is the same as 2 times 4, or 8, with a negative sign attached to it, because a negative times a positive is negative. So this is negative 2x plus negative 8, or you can rewrite this as negative 2x minus 8. Either way is correct. And for the second one, we have negative 3 times x times y and times 7. So that is negative 3x plus negative 3 times y. Make that a bit more of a minus sign there. Plus negative 21. As the 3 is multiplied by each of the different terms in the expression in parentheses. Now again, we can rewrite this as negative 3x minus 3y minus 21, if you like, but you can leave it in either way that you want. Another set of examples, if we have some subtraction going on instead of just addition, with a positive number being multiplied by the expression in parentheses. So for the one on the left, we have 4 times x minus 4 times y. Again, just keep the operation. And in the second one, we have 8 times x rather, which is 8x, plus 8 times 6, which is 48. Now minus 8 times g. One more set of example problems before we get to your practice ones. We have a negative 4 times x minus 7 and a negative 8 times x minus y. Again, I encourage you to pause the video and try to work through these problems before we review it, but you are welcome to just watch through until we get to the final practice problems at the end. Negative 4 times x and negative 4 times 7 becomes negative 4x minus negative 4 times 7 is negative 28. Now here we have negative 4x minus a negative 28. And we can leave it like this because this is technically correct. However, it is a little bit sloppy to write minus negative 28. So if we use that same strategy that we do in subtraction, the one we remember how the process goes by using the trick KCC. We're going to keep the negative 4x, change the subtraction to an addition, and now this negative 28 becomes a positive 28, so it's the same as negative 4x plus 28. And this is the way I prefer that we write everything when we go through distributive property problems in class or in homework or on assessments, where we end up with minus a negative. And finally, in these initial example problems, negative 8 times x minus negative 8 times y. Again, keep, change, change, so it becomes negative 8x plus 8y. So those are the initial example problems. We've gone through pretty much every scenario with the distributive property that we could. So let's take a look at some problems for you to pause the video with, work on your own, and then come back when you're ready to look at the actual answers of the distributed expressions. We have these two problems here and two problems on the next page. So go ahead, pause the video, work on these, and when you are ready to come back. So on the left-hand one, we have 7 multiplied by everything, so 7 times x minus 7 times y plus 7 times 6, which is 42. So this is the expression that we want, 7x minus 7y plus 42. On the right-hand one, negative 3 times 8. 3 times 8 is 24, so negative 3 times 8 is negative 24 plus negative 3y, or alternatively, negative 24 minus 3y. Either way is correct. And for our last two problems, here we go. 12 times x plus y minus 8, and negative 4 times a minus 7 plus b. So here we have 12 times x plus 12 times y minus 12 times 8, and 12 times 8 is 96. So this is the answer that we want. 12x plus 12y minus 96. And finally, for the last one, we have negative 4 times a minus negative 4 times 7, which is negative 28, plus negative 4 times b. Now remember that anytime we have minus a negative, we are going to make that plus a positive by using the subtraction changing rules for add the opposite, the ones that we remember with the trick KCC. So overall, this becomes negative 4a plus 28 plus negative 4b, which can be rewritten as minus 4b, but I won't rewrite that whole thing now. So either that or with a minus 4b at the end. One way or another, that is correct. So just a quick review, the distributive property takes a number multiplied by a sum or a difference in parentheses. It could be a long or a short expression containing sums or differences, and multiplies that number out over every single part of the expression within the parentheses. Now with regular numbers, we're probably going to just add or subtract whatever's in the parentheses rather than distribute, although distributing can sometimes be really helpful in that one. But really where it's helpful is using the distributive property on expressions that have variables in it when we want an answer that's really not just a number at the end. We want an expression or a phrase such as 3x plus 12 or 28 plus 4y.